Think about this. You exist. You're lying here, breathing, thinking, aware. But have you ever stopped to wonder why there's anything at all? Why there's a universe? Why there's matter? Why there's you? Hello, and welcome to the 67 Sleepy Facts channel. Tonight, we're going to explore the deepest cosmic mysteries science has ever encountered, not with complicated equations or technical jargon, but as a journey through wonder itself. These are questions that have puzzled the greatest minds in history, mysteries that remain unsolved despite centuries of investigation. And as we drift through them together, let their vastness and beauty carry you into peaceful rest. Let's begin with the most fundamental question of all. Why does anything exist? Right now, at this very moment, you are made of atoms that were forged in the hearts of dying stars billions of years ago. The universe around you contains galaxies, black holes, planets, and life. But science cannot answer the simplest question a child might ask. Why is there something instead of nothing?
Physics can tell us how the universe behaves once it exists. We can trace its story back nearly 14 billion years to a hot, dense beginning. But why there should be a universe at all? Why there are laws of nature that allow reality to exist remains completely unexplained. It's as if the entire cosmos, everything you've ever known or ever will know, rests on a foundation made of question marks. Some philosophers have suggested that existence is simply the natural state, that nothingness is actually impossible. Others propose that our universe might be just one bubble in an endless sea of universes, each with its own reality. But even if that's true, it only pushes the mystery back one step. Why should any of it exist at all? This question sits at the root of everything. Every star in the night sky, every cell in your body, every law of physics exists on this unexplained foundation. It's a mystery so profound that we rarely even think about it in daily life. Yet here it is, the deepest puzzle we face. And from this mysterious beginning, the universe began to unfold in ways that still perplex us. Nearly 14 billion years ago, everything we can see was compressed into an unimaginably small point. Then it began expanding rapidly, a moment we call the Big Bang. But here's what keeps scientists awake at night. We don't actually know what caused it. Something triggered the most dramatic event in cosmic history, and we have no idea what that something was. Think about that. We can describe in exquisite detail what happened mere fractions of a second after the universe began. We can map the afterglow of creation still visible in the sky today. But the actual spark that set everything in motion, that remains hidden in darkness. Some theories suggest it was a quantum fluctuation, a sort of cosmic hiccup in the fabric of reality itself. Others propose that our Big Bang wasn't the first, that universes might be born, expand, collapse, and be born again in an endless cycle. But without a way to look beyond or before our own cosmic beginning, these remain educated guesses rather than answers. What makes this even stranger is that the universe didn't just expand, it's still expanding, and not just that, it's expanding faster and faster.
In the 1990s, astronomers expected to find that gravity was gradually slowing down the cosmic expansion. Instead, they discovered the opposite. Galaxies are accelerating away from each other, pushed by something invisible that fills empty space itself. We call this mysterious force dark energy, though that's really just a name for our ignorance. It makes up nearly 70% of everything that exists in the universe. 70%. That means most of reality is something we cannot see, cannot touch, and barely understand. Imagine if someone told you that 70% of your own body was made of something invisible and unknown. That's the situation we're in with the universe. This dark energy could be a property of space itself, a kind of inherent energy woven into the vacuum. Or it might be something even stranger, pointing to new laws of physics we haven't discovered yet. And the consequences are profound. If dark energy continues at its current strength, the universe will keep expanding forever. Galaxies will drift so far apart that future civilizations might look up and see a sky with no other galaxies at all, alone in an ocean of darkness. But if dark energy grows stronger over time, it could eventually tear apart galaxies, then solar systems, then planets, then atoms themselves. But dark energy isn't the only invisible presence shaping the cosmos. Between these mysteries of dark matter and dark energy flows something even more familiar, yet equally puzzling: time itself. Time always moves forward, always. You remember yesterday, but not tomorrow. A cup falls and shatters, but the pieces never leap back together. Heat flows from your warm coffee into the cool air, never the reverse. Every moment, without exception, the present becomes the past, and we flow inexorably toward the future. This one-way nature of time is so fundamental to our experience that we rarely question it. But here's what makes it strange. The fundamental laws of physics don't require time to flow in only one direction. At the smallest scales, the equations that govern how particles behave are completely reversible. A particle moving forward through time follows the same rules as one moving backward. The mathematics is symmetrical, showing no preference for past or future. So why does our entire universe insist on moving only one way through time? Why can't we unscramble an egg, or unspoil milk, or watch a broken vase repair itself?
Scientists often connect this arrow of time to something called entropy, which is essentially a measure of disorder. The universe began in an incredibly ordered state, and it's been getting more disordered ever since. It's like a deck of cards that starts perfectly sorted and gets more shuffled with each passing moment. But this explanation only pushes the mystery back one step. Why did the universe begin in such an exceptionally ordered state? What set up those initial conditions that allow time to even have a direction? Some physicists think the arrow of time emerges from how information spreads through the universe, becoming impossible to reverse as it disperses. Others suggest it's tied to the expansion of space itself, time and space flowing forward together. But none of these explanations feel complete. We live inside time, experiencing its flow with every heartbeat, yet the reason it flows forward and only forward remains hauntingly unexplained. Look upward into the night, and you see only the smallest island of reality. Beyond our horizon lies the unobservable universe, forever sealed from our instruments by the finite speed of light and the age of creation itself. There may be endless regions out there, perhaps similar to our own,
perhaps governed by entirely different principles. We are bound within our cosmic shore, unable to glimpse what lies beyond the edge. Some whisper that our universe might not be unique, that reality could be vaster than we dare imagine, filled with countless other universes, each budding off with its own laws and constants. If true, we inhabit merely one bubble in an infinite froth of creation. But such ideas hover at the boundary between science and philosophy, tantalizing yet untestable, beautiful yet uncertain. Within our own corner of existence, particles behave in ways that defy intuition. A single speck of matter can exist in multiple places simultaneously, spreading into a cloud of possibility until observed. When two particles become entangled, they remain connected across any distance, their fates intertwined despite the void between them. The universe whispers across space, keeping hidden ledgers of correlation we cannot explain. Deep within black holes, gravity grows so fierce that nothing escapes, not even light. At their hearts, our equations predict something impossible: infinite density, infinite curvature, places where mathematics itself breaks down. Are these singularities real, or do they point to the limits of our understanding? When matter falls inward, does it truly vanish, or is information somehow escape in ways we cannot yet perceive? Stars themselves hold secrets. The very first generation, born when the universe was young and simple, have never been observed. They would have been giants, burning bright and brief, forging the first heavy elements before exploding across the void. Their light has long since faded, leaving only traces we struggle to read in the chemistry of later stars. At the centers of galaxies, supermassive black holes grew impossibly quickly, reaching billions of solar masses when the cosmos was still in its infancy. By all known processes, there wasn't time for them to feed and grow so large. Something we don't yet understand allowed these giants to form, shaping the galaxies around them, influencing the architecture of the universe itself. Across the cosmic web stretch vast voids, nearly empty of galaxies, hundreds of millions of light years across. They are among the loneliest places imaginable, great absences in the fabric of matter. How they grew so large, whether they hint at deeper principles of cosmic structure, remains debated. Looking into such emptiness is like staring into nothingness on the grandest scale. Between these voids and clusters, pulsars spin with astonishing precision, their beams sweeping space like cosmic lighthouses. Some rotate hundreds of times a second, keeping time better than our finest atomic clocks. How such extreme objects maintain such stability, occasionally glitching in ways we cannot predict, speaks to physics we're only beginning to grasp. They are laboratories of the impossible, dense beyond imagination. From unknown sources, the universe sends us fast radio bursts, powerful signals lasting mere milliseconds. Each one releases energy equivalent to what the sun produces in a year, compressed into the blink of an eye. Some repeat, others appear once and vanish forever. Are they the cries of magnetars, the echoes of cosmic collisions, messages we're only beginning to learn how to read? Cosmic rays strike our atmosphere constantly, most from familiar sources, but the most energetic defy explanation. Single particles carrying the energy of a thrown baseball should not exist. No known process should accelerate them to such extremes. Somewhere in the cosmos, nature operates particle accelerators beyond anything we can build. firing projectiles across unimaginable distances. Our own galaxy spirals gracefully, arms curving outward in patterns both beautiful and mysterious. Why do so many galaxies take this form? Are the arms density waves, or are they shaped by gravitational interactions, or something else entirely? The answer shifts depending on which galaxy we examine, suggesting the universe has many paths to similar beauty. On our own world, life arose more than 3.5 billion years ago, but the moment chemistry became biology remains hidden. How did non-living molecules cross that threshold into self-replication, into evolution, into the ancestor of all living things? Was it inevitable once the right ingredients gathered? Or was it a singular accident, unlikely to be repeated anywhere else in all the cosmos? The spark could have ignited in deep ocean vents, where hot water and minerals met in darkness, or perhaps in shallow pools on land, where cycles of drying and filling concentrated chemistry and energy. The first cells, the first membranes, the first genetic codes all emerged somehow, but the full story is lost in deep time. All life on Earth uses the same elegant molecule to store information, a double helix that carries instructions for every organism. Why this particular solution? Was it the only possibility, or simply the one that happened to work? The universality of this code suggests something fundamental, yet its origins remain clouded. Viruses blur the line between living and not, ancient and adaptable, yet their beginnings are unclear. Were they fragments of genetic material that learned to copy themselves? Relics from before cells evolved? Or perhaps once living things stripped down to their essence? They shape evolution, transfer genes, and influence the course of life in ways we're still uncovering.
Consciousness arises from flesh and electricity, yet the leap from neural firing to inner experience cannot be explained. You are aware of these words, of your breathing, of the softness beneath you, but why should arranged matter create the feeling of being? A brain scan shows activity, but it cannot capture the redness of red, the sadness of a song, the sensation of existing. This is the deepest mystery of all. Each night you drift into dreams, vivid worlds conjured from memory and imagination, dissolving upon waking. Why the brain creates these nocturnal journeys remains uncertain. Perhaps they process emotion, rehearse challenges, consolidate learning, or perhaps they are simply the mind's way of organizing itself during rest. Whatever their purpose, they remain mysterious companions of the dark. Time in the mind stretches and compresses, moments of fear extending into eternity, while hours of joy vanish in an instant. The clock ticks steadily, but your experience of duration bends according to rules we don't yet fully understand. Novelty expands perception, while routine compresses it, which might explain why childhood seemed endless, while recent years slip past more quickly. Memories are not stored like files, but woven across networks of neurons, changeable and fallible. Sometimes we recall events that never happened, completely convinced of their truth. Why some moments last forever, while others fade in days, remains mysterious. The machinery that makes you who you are, that carries your past forward into each moment, still holds secrets. Emotions surge through body and mind, ancient responses to the world around you, yet their origins are debated. Are they hardwired survival tools or constructed interpretations shaped by culture and memory? Fear, joy, sorrow, and love guide your choices more than reason. Powerful forces arising from biology we're only beginning to map. Creativity appears in flashes, sudden connections emerging from nowhere. An artist sees a vision, a scientist grasps a solution, and no one can explain the moment inspiration strikes. Perhaps it's the subconscious mixing old patterns in new ways. Perhaps it requires stepping away, letting the mind wander. The spark of something from nothing remains beautifully inexplicable. Occasionally, you experience déjà vu, the uncanny feeling that this moment has happened before. Is it a misfire of memory, one brain region processing experience slightly before another? Or similarity between present and forgotten past fooling perception? Whatever the cause, for a few seconds, reality feels doubled, both new and remembered.
The placebo effect demonstrates the power of belief itself to heal. Even when people know they're taking sugar pills, expectation can trigger real changes in the brain and body, releasing natural painkillers, altering chemistry, affecting immune function. The line between mind and body blurs in ways that remain partly mysterious. Every creature on Earth surrenders to sleep, despite its dangers. In the wild, sleeping means vulnerability, yet evolution preserved this need across all species. Why we spend a third of our lives unconscious remains incompletely understood. Sleep may clear waste from the brain, consolidate memory, restore energy, but no single explanation captures its full purpose. Aging unfolds with predictable inevitability, yet science cannot fully explain why we grow old or why we age so differently from other creatures. Some turtles show almost no decline. Certain jellyfish appear to reverse their aging entirely. Naked mole rats live far longer than similar animals, resistant to diseases of age. The mechanisms that wind down our cells remain partly hidden, though unlocking them could transform medicine. A salamander loses a leg and grows a new one, perfect in every detail. Humans share many of the same genes, yet our bodies cannot perform this miracle. If we could unlock this ability, hearts could heal themselves, spinal cords could regrow, but the blueprint of regeneration remains beyond our grasp. Whales glide through Arctic waters for centuries, their massive bodies somehow resistant to cancer despite having trillions of cells and ample time for mutations. They've cracked part of the code of long life without disease, but their secret drifts beneath the waves, unsolved. Birds sense Earth's magnetic field, navigating thousands of miles with uncanny precision. Tiny warblers fly from continent to continent, arriving at the same groves year after year. How they perceive this invisible layer of reality, how they pass this knowledge between generations remains uncertain. For them, the world carries directions written into its fabric, a compass we cannot read. Homing pigeons released hundreds of miles from home circle once and fly straight back, guided by senses we don't fully understand. Even under cloudy skies in unfamiliar places, they find their way. Is it magnetism? Scent? The sun? None fully explains their ability. The secret compass remains hidden in their biology. Language sets humans apart, allowing us to share what isn't present, to plan, to dream, to imagine. But how our ancestors made the leap from simple calls to structured speech is lost in time. Perhaps it began with hand signals or rhythmic sounds that gradually became words. The first conversations left no trace, only the certainty that something profound happened in our distant past. Laughter crosses all cultures, all ages, a universal sound of joy. Yet why we laugh and how it first evolved remains uncertain. It may have begun as a signal of safety, turning fear into relief. Or perhaps it started with playful primates. Whatever its origin, laughter bonds communities, releases stress, and carries power beyond its simple mechanics. Music moves us in ways nothing else can. A melody can bring tears, a rhythm can synchronize heartbeats across a crowd, a song can unlock memories thought lost. Why organized sound reaches so deeply into our minds has no clear explanation. Stroke patients who cannot speak can still sing. People with dementia remember lyrics when almost everything else has faded. Music remains one of the most universal, mysterious forces in human existence. Love binds us, inspires sacrifice, shapes lives more than almost anything else. Biology shows us chemicals flooding the brain. Evolutionary theories suggest strategies for raising offspring, but these don't capture the full experience. Why it arrives suddenly, or lasts a lifetime, or fades away, why people risk everything for it against reason remains beyond complete understanding. Across separate cultures with no contact, similar myths emerge: great floods, trickster spirits, journeys to underworlds. Are human minds wired for certain stories? Did ancient myths spread through forgotten migrations? Or do symbols arise from deeper patterns in consciousness itself? The strange recurrence of similar tales across the globe remains puzzling.
Humans cooperate with strangers in ways that defy simple evolutionary explanation. We donate blood, build communities, sacrifice for people we'll never meet. This willingness to help beyond family and close allies, this moral instinct that seems written into our minds, is one of humanity's most beautiful mysteries. Civilizations rise to greatness and then collapse, mighty empires vanishing into silence. Climate, war, resources, corruption all play roles, but the deeper forces driving these cycles remain debated. The patterns repeat across history, suggesting something fundamental about how complex societies grow and fall. Curiosity itself defies easy explanation. Why do we wonder? Why look at stars and ask questions no other creature asks? It goes far beyond survival, pushing us to study galaxies billions of light years away, to decode ancient languages, to seek answers with no practical purpose. This restless drive to understand seems built into us, but its source remains unclear. Storytelling is universal, found in every culture, around every fire. We weave words into narratives, create worlds that never existed, feel emotions for people who aren't real. Why we need stories, why they linger in our minds for years, why no other species does this, points to something fundamental about being human. Lightning sometimes forms glowing spheres that drift silently through the air, even passing through windows. For centuries dismissed as myth, credible sightings and recordings confirm ball lightning is real. yet no one knows what it is. Theories suggest trapped plasma, vaporized silicon, chemical reactions, but none fit every account. It remains one of nature's strangest phenomena. During powerful earthquakes, witnesses report glowing lights in the sky, flickering flames along the ground, strange orbs above fault lines. What causes these earthquake lights remains unknown. Perhaps stressed rocks release electrical charges, or tectonic forces ionize gases. Their rarity makes them difficult to study, eerie glimpses of Earth's hidden processes.
Some volcanoes erupt with catastrophic fury, blasting enough material into the sky to alter climate across continents. What tips the balance from dormant silence to devastating explosion remains uncertain. The inner mechanics of supereruptions are hidden, reminders that Earth itself holds power we have yet to master. Our planet's surface moves, continents drifting, mountains rising, oceans opening and closing, all driven by plate tectonics. But why this began on Earth and not on Mars or Venus remains debated. Perhaps water acted as lubricant, or internal heat reached a precise balance. Without this restless churning, the climate-regulating carbon cycle might fail, leaving the planet barren. Water covers most of Earth, essential to life, yet its origin is uncertain. Did asteroids and comets deliver it during the solar system's violent youth? Or was water present from the beginning, trapped deep within the planet? The chemical signatures don't always match, leaving the question open. Every drop carries the mystery of its origin. The moon's far side looks strangely different from the face we see, rugged and mountainous rather than smooth with dark maria. Why the two hemispheres differ so dramatically defies simple explanation. The moon should be symmetrical, yet it isn't, as though half remains a stranger to us. Deep beneath our feet, Earth's core of molten iron and nickel generates the magnetic field that shields us from solar winds. Without it, our atmosphere might be stripped away like Mars. But despite its importance, we cannot drill to the core, relying on indirect clues to understand how it works. The beating heart of our planet remains hidden from direct study. Every so often in Earth's history, the magnetic poles switch places, north becoming south. The exact trigger is unclear, turbulence in the liquid core becoming unstable, causing the field to collapse and rebuild reversed. During reversals, the weakened field exposes Earth to more radiation. The effects on ecosystems remain uncertain. For millions of years, climate has swung between ice ages and warmer periods, glaciers advancing and retreating, carving landscapes and reshaping continents. Changes in Earth's orbit and tilt alter sunlight patterns. Volcanic eruptions inject particles into the atmosphere. Ocean currents shift, but the full mechanics driving these cycles remain debated. 5 times in Earth's history, life nearly vanished in mass extinctions. Asteroid impacts, supervolcanoes, climate shifts, and changing oceans have all been implicated. Why some species survive while others perish, why some extinctions unfold slowly while others strike suddenly, remains only partly understood. Each cleared the stage for new forms of life to rise. Saturn's rings, among the most beautiful sights in the solar system, appear strangely young and clean. If they were as old as Saturn itself, they should be darker, dirtied by impacts over billions of years. Perhaps a moon wandered too close and was torn apart. Perhaps comets shattered. We may be living in the brief era when Saturn wears this crown. Uranus rolls through space on its side, its axis tilted almost horizontally. A colossal impact might have knocked it over, or multiple smaller collisions, or gravitational interactions with other planets. Whatever the cause, Uranus remains unique, its sideways spin creating bizarre seasons and influencing its oddly offset magnetic field. Venus rotates backwards, the sun rising in the west and setting in the east. A single day there lasts longer than its year. Was it struck by a massive object? Did tidal interactions with the sun reverse its spin? No theory fully explains the planet we see today, turning slowly backwards beneath perpetual clouds. Neptune, so far from the sun, howls with winds faster than any on Earth and is racked by storms the size of planets that appear and vanish without warning. Why such violent weather exists in the frozen reaches of the solar system, powered perhaps by internal heat, remains partly mysterious. Jupiter's great red spot has swirled for at least 3.5 centuries, a storm that could swallow Earth whole. Why it began and why it has lasted so long remain unclear, and in recent decades it has been shrinking. Will it fade away entirely, or does it follow cycles we don't yet understand? Comets sweep in from the edges of the solar system, visitors from a vast reservoir called the Oort cloud, thought to contain trillions of icy bodies. Yet, despite being the source of comets, it has never been observed directly. The great unseen frontier of our solar system remains a ghostly shell surrounding us. Europa, Enceladus, and other moons hide oceans beneath shells of ice, kept liquid by the gravitational pull of their planets. These hidden seas may be larger than all Earth's oceans combined. What strange forms of life might swim in such darkness? Until we explore beneath the ice, the answer waits. Saturn's small moon Enceladus sprays geysers of water into space from cracks near its south pole. These plumes contain salts, organics, and signs of chemical reactions that on Earth would hint at life. What drives these eruptions, whether hydrothermal vents warm the seafloor below, remains unsolved. Titan has lakes and seas, rivers and rain, but all made of liquid methane instead of water. Sunlight should destroy the methane in Titan's atmosphere over time, yet the seas remain full. Something keeps replenishing them, whether cryovolcanoes releasing methane from the interior or processes we don't yet understand. Mars was once a world of flowing rivers, deltas, and perhaps oceans. Today it is dry and frozen. What happened to all that water? Some may be locked as ice beneath the surface, some trapped in minerals. Much escaped into space when Mars lost its magnetic field. The full story remains unclear. Mathematics describes the universe with uncanny precision. Equations dreamed up on paper govern stars, atoms, and galaxies. Einstein's formulas predicted black holes before anyone saw one. Why should abstract symbols map so exactly onto reality? Whether math is discovered or invented,
Whether it reveals truths built into the cosmos or is simply a tool shaped by human minds remains debated. Every law of physics rests on constants: the speed of light, the charge of an electron, the strength of gravity. Why they have the values they do, no theory explains. Change them slightly and stars might never form. Chemistry might not exist. Life might be impossible. They are like settings on a cosmic dial, fixed, precise, and unexplained.
At the quantum level, particles behave unpredictably. Is this true randomness or just complexity beyond understanding? Einstein believed hidden laws must govern quantum events, but experiments suggest otherwise. Whether the universe is fundamentally ordered or truly random remains unanswered. Time bends and stretches depending on speed and gravity. A clock on a mountain ticks faster than one at sea level. Why we experience time as a one-way arrow, why the past feels fixed while the future remains open, cannot be fully explained. Some think it's tied to entropy. Others suggest time might be an illusion. Its true nature remains profound and mysterious. When the universe began, equal amounts of matter and antimatter should have been created. When they meet, they annihilate into pure energy. If perfectly balanced, everything should have disappeared in a flash. Yet here we are. Somehow, matter won. The tiny asymmetries that tilted the balance don't seem large enough to explain why anything exists at all. Everything around us has mass, but what gives particles mass remains partly mysterious. The discovery of the Higgs boson confirmed an invisible field pervades the universe. As particles move through it, they acquire mass. But why the field exists, why it has the strength it does, why different particles interact with it so differently, opens deeper questions. At the smallest scales, physics may not be smooth but granular, made of tiny indivisible units. This smallest length, the Planck scale, is far beyond observation. If reality is pixelated, space and time themselves are not continuous but have a fundamental texture. Whether such a limit exists remains one of the deepest mysteries. The laws of physics could have been different. Why this set of laws and not another? Why a universe where stars can form instead of one where matter collapses or drifts apart? Some imagine countless universes with different rules. Others think deeper principles fix the laws in place. The origin of the laws themselves remains unexplained. Perhaps the greatest mystery is not the universe, but our place within it. Whether human minds can ever truly comprehend the totality of reality. Each answer reveals more questions. Each discovery opens new mysteries. There may always be questions just beyond reach, woven into the fabric of existence.
As you drift towards sleep now, hold this thought gently. Curiosity itself is part of the mystery. To wonder is to be human. To seek is to be alive. The questions may never end, but neither will the search. Let your breathing fall into rhythm, soft and steady. Let your body grow heavy, sinking into rest. Imagine yourself floating through these mysteries, passing by them like constellations in the night. Questions above, questions below, a galaxy of wonder all around you, and you at the quiet center. There is nothing left to do now, no answers to chase, no puzzles to solve. Only the calm certainty that mystery itself is a kind of lullaby, carrying you gently into sleep, into dreams, into the vast and beautiful unknown. Rest well, traveler. May wonder fill your dreams.